So as a recap, yeah, so how did people feel about that? Now, what was your experience? Maybe just a few people had a curveball. Okay. What was the curveball?
My AV couldn't detect me outside the car.
Oh no.
The door was locked.
So the AV couldn't detect you and the door was locked. Okay. It's tough. Any really weird situations that came out from your role play? Yeah.
Car drove to find parking and then it lost its GPS signal, so now it doesn't.
Tried to find parking but lost its GPS signal. Okay. Yeah. Anybody else? Yeah.
I couldn't legally leave the child in the car and the passenger
I couldn't. Yeah, you couldn't leave the child in the car legally. That's fair. Yeah, fair enough. Anything else? Yeah.
Situation when you go to a shopping center to pick up where it's not mapped well. Where do I drop someone off? Where do I pick them up?
Yeah. So shopping center maps are not very good, and so where do you drop and pick them up? Basically, yeah. Anyways, so that's a very small taste of role play, right? And there's actually more complicated versions of this, like wargaming or scenario play. But the idea of role play can be something that is incredibly low tech, but helps you identify a lot of very interesting issues. And so from here, maybe you at least have some empathy, maybe as the AV for the passenger, and maybe vice versa. And then when you're done with an exercise like this, you have a list of notes that come from not only the people that were acting and the creative director, but potentially the people that were watching that take place as well. So it's a really important and interesting thing when we're talking about, you just basically prototyped how an AV should interact without using anything other than just two people. So. Cool. So when we talk about prototypes as well, I think it's important to talk about both non-coded and coded prototypes, right? We just did something that was absolutely not necessary to, any type of prototype, but one of the ones that we use, so this is an example of the screen for the dispatcher that would do for a particular job that was going to be a job that would come in. A bunch of work would happen by the dispatcher and the field tech. It would be assigned, and then there would be work that would happen afterwards. And so in this particular case, we built this prototype with a lot of different aspects. So the install, the recommended time frame, and recommended parts, those were all potentially systems that would do prediction or recommendation. The automatic scheduling and other things like that was behind all of this. And then the part that's really in that right-hand side is a shared chat view for everybody that's working on it. And it also has a bot, kind of, that is including people that may have good expertise. So including what we call like senior field techs to help understand a situation. But also just talk about what is going on with this job, if there's automatic status updates, for example. So there were a lot of things that we could do where there was fleet tracking, being able to say when, give the dispatcher information automatically about the location of the field tech en route to that place, right? If she gets a call from an angry customer. So anyways, this is an example of something where we were testing out a lot of different things, but we did it in a way that was not coded at all up front. And so this was just done in Sketch, pushed into Envision, and that's the way it worked. There's also two other methods that I think are important when we talk about coding these types of systems from a prototyping aspect. So one of them is what's called Wizard of Oz, right? So Wizard of Oz, if you're not familiar, and spoiler alert, the person behind the wizard is actually just this guy behind the curtain. But what it means when we talk about prototyping, when we talk about design, Wizard of Oz is that you have some type of facade that looks like it's a machine. And it acts like a machine, but behind it is actually people. And there's been a few articles that posit that maybe most machine learning is actually just this anyways. But this is very helpful when you're trying to understand, if you have like an idea about what the problem is and you have an idea of what the solution could be, that would be helpful. And you want to understand how people interact with a system where the expectation is that it's a system itself rather than a person, right? So there's a big difference between this and interacting with a human being. Is you probably have expectations that if it's a website that looks good and is well put together, that it will function properly, right? And so what happens when it doesn't in the case of the prototype? Also, when it comes to the aspects of what my expectations or assumptions are about the way the system will like evolve over time. Probably a Wizard of Oz system will not evolve as much because while it is gaining context about my understanding and it could be very personalized, it's still just a website or it's still just an application. So I think that's something that's very interesting to consider. And the other one is what's called concierge. And so concierge is the opposite of that, where you generally dumb down or reduce the fidelity of like the interactions that are taking place to just a chat or some type of conversation experience where, and this one's very helpful if you don't actually know what all the problems are. So like if you've done the empathy and the definition step and you're still not quite sure what's going on, you can start to prototype using a concierge service. And we did something like this at Philosophie where we're working for, again, through that partnership between PwC and Google, working with Sky, which is a satellite provider in Mexico, we were building out concierge-style prototypes for their salespeople. And in Mexico, the way that satellite sales works is it's still very door-to-door. It's still very paper and pencil. And so people were walking around neighborhoods and trying to sell people satellite TV, basically. And so rather than build out something that's like a complicated tablet app or something like that, we just used WhatsApp. To interact with them on a regular basis, to help them understand where they, what things would actually help them with regards to leads lists, how they should update the status of the different things that they're doing. But this idea of concierge is a really interesting thing. Now, the expectations that people have for concierge, and this is part of the reason why I think chatbots don't work a lot of the time, is that they expect to be able to have regular human interaction, which is something that doesn't work when it comes to most bots today. And so, anyways, this is like two sides of a coin. It's like, which one do you think is actually more important? Do you want what them to assume is a cold and calculated machine? Or do you want it to be that it's more of like a squishy human that they can interact with? And so, yeah, you had a question.
I feel like with chatbots, there's a lot of ambiguity because some chatbots are explicitly wired to say, don't treat me like a human.
That's right.
Tell me.
Totally.
And other chatbots are wired such that if you try to just get your information from them in a minimalist way, they're like, no, have a conversation. So
Yeah.
with chatbots being in this sort of liminal state, it
Yeah.
can be hard to know what to expect.
Totally. No, I think you're absolutely right. And that's where, when we get into this idea of trust and expectations of things, it's really important because it's not just how you are like showing yourself as an application or a service, right? It's about everything that they've used in the past as well. And so we've been trained for tens of years at this point to have chat experiences, right? Like SMS, ICQ, if you want to keep going back, like MUDs and blah, blah, blah. But like that idea of how you have these conversations is really, really important, right? And so we think about conversations all the time in a very digital way. And so that's why when things are in this liminal state, as you put it, right, like it doesn't work out as well. You need to do a lot of expectation setting. And it's interesting because when you look at something like, say, Google Duplex, right, and the way that they're trying to, it's a very kind of closed case where they're going after particular needs in a way that is probably branching in a way that is much more simplistic. And again, if people know or don't know, they may not like try to test it with crazy, they're not trying to do a Turing test every time, right? I think the problem with chatbots, once people detect it's a chatbot, is they swear at it. They probably try to screw it up in some way, right? So anyways, there's a lot of interesting things there about trust and accountability as well. So yeah, absolutely agree. Cool. And this is an example of prototyping that was done by a woman and her team at Stanford. And so she's named Wendy Ju. Actually, I don't think you need the sound on this, but essentially, this is like an automated trash can. And so this automated trash can was done in Stanford, and it talks a lot about so. It has a camera on it. It will actually operate, it will move around a space to try to collect trash. And so you can see people starting to wave trash at it. People start to interact with these systems in a very particular way. It would shake when it was near someone to kind of show, hey, I want some trash from you. So that's a very good question. Yeah, and so in this case, kids would try to bait the thing with trash to come over to somewhere where I could disassemble the trash can probably. Yeah, so the question is this actually autonomous, right? And it's not in this case. In this case, what they did a lot of is they'd use, in this case, it was a trash can with cameras and kind of a remote control base, but there would be what Wendy or Dr. Ju would refer to as puppeteers, right? And so they're really adept at kind of creating these like micro emotions within these things, right? And so a lot of totally ignore like it's such an interesting study. So she's also done work with autonomous vehicles where it was actually a person sitting in the seat, but they were wearing this like thing that was a seat on top of them. She's done things where there was an autonomous ottoman that would try to like get under your feet while you were sitting in a chair. And so none of these things though are autonomous in any way. But what they're doing is they're testing interactions between human beings and robotics or embodied intelligence, right? And so, anyways, I think this is some really, really amazing work that you should check out. And she's doing a lot of stuff also with kind of virtual reality in a car, in a vehicle that's moving to be able to test different types of things like the perception of an accident actually happening while you're driving in a car. It feels really real when you're wearing VR and then you're sitting in the passenger seat and you see a car about to hit you, right? And so they've done a lot of work around this. So, one of the things that she started to piece together, mostly because autonomous vehicles are so popular right now, is this system called WAS, which is essentially a rigged up prototype where people are driving in the car and they're trying to understand when they should interrupt people or not. And they're using this to collect lots and lots of data to also start to train the actual interactions that take place between machines and human beings. And this is actually done, I think it's basically an Alexa with a laptop and then some control stuff in the back of the car. And then they have this web interface that they've created to make it sound and appear like it's an Alexa just interacting with the driver. So you don't have to build any of these things, right? You can test so many interesting applications of this human and machine interaction through prototyping without having to go and actually figure everything out. So I think that's something that I just want always people to keep in mind. So now that we've talked about prototyping, let's talk about testing, right? So part of that, just the collection of that data, for example, which starts to actually feed a machine learning algorithm in itself, you need to do this testing. And I usually, it's always hard to talk about prototyping without testing and vice versa, because you need to have something that you can talk about, even if it is just symbolic. And so testing in this case, it goes hand in hand with prototyping. It's really how are you getting it into the hands or in front of the people that are the focus for your human-centered AI in this case. And one of the very key aspects of it that I've been alluding to for this entire tutorial is really around trust. And this goes back to a story about a startup that I ran for a little while called Complete Seating. And so Complete Seating was basically an open table competitor. We did an awful lot of work to help. It wasn't necessarily from the marketing aspects. It wasn't a consumer brand in any way, but it was to help make the role of the host or the manager much more efficient in how they manage their dining room floor and reservations that were coming in, basically. And a lot of our job was to, first of all, automate as much as possible when it came to the time before the guest gets to the restaurant, and then to take a step back and assist the host as much as possible after the guest is at the restaurant. This is a very crappy early version of it. And one of the mistakes that we made, right, was we were a beta service. We were building out something that was pretty interesting, actually. And you can see in the upper right-hand corner, there's kind of like 1 to 2 now, 3 to 4 now, 5 to 6, 2 hours and 45 minutes. This was understanding the actual map of the restaurant of the tables and how they can combine, which is not straightforward. Like if you put 2 4-tops together, it does not make an 8-top, it makes a 6-top. But also, the fact is that we need to do a prediction task to try to understand how long someone will actually sit at a table. So this is like a classic computer science kind of job queuing problem. Right? People are the jobs. You need to figure out how long they'll take, what resources they need, and then the resources of the tables, and you can combine them in a lot of different ways. And it's a very NP complete type of problem, right? Like you can create tons and tons of different options. And so it's very much like around, we were doing a lot of things that were fairly deterministic in this case. We were judging fitness of different seating maps and things like that. But prediction was the main task that was interesting here. Now, the mistake we made up front was that rather than just trying to help hosts avoid making errors, which is that if you seat this person here, you will have a cascading effect on all these other reservations. But we tried to actually do their job actively. And so in the middle, you see the tables column. Those were actually recommendations by the system itself on how all of these things should be penciled in. The locks were the ones where they would actually do it. Now the problem is that because we were a brand new service, we were in only a few restaurants at the very beginning, we were buggy. And unfortunately, when you're buggy and you're trying to use a system that people depend on, they don't trust it anymore. And so in this particular case, we were trying to do too much of their job up front rather than trying to maybe prove the negative as is being discussed in Tesla, right? So the idea of Tesla's not building autonomous vehicles, but they have autonomous vehicle software that's monitoring everything that everybody's driving with. Right? And so anyways, this is just like an example of where, very viscerally, this was not the only reason why we failed, by the way, but it was a main one, I would say. So this gets to, as part of my research into automation and trust, this is a very seminal paper by Parasuraman back in '97. And so he really breaks down, him and his co-authors really break down automation and trust within human beings into 4 different cases: use, misuse, disuse, and abuse. And you can read this paper, it's pretty good. A lot of the papers that came out in academia, say 20 to like 30 years ago, would mostly focus on automation from the standpoint of aviation, because we've basically been having planes that can fly themselves for a very long time, or academic kind of student testing type of stuff. So the research is definitely a little bit more limited than what we have today, and I'm very interested to continuously see things that are coming out around that. But I think this is very important. So use is really the voluntary activation or disengagement, and that's a key aspect here. Disengagement as well, right? So starting to use and stopping to use a particular automation by humans. And what's important about this use case is that that's actually the just amount case of trust, right? That's where people trust the system in the right way, that they utilize it when they should, basically. The next aspect is misuse, okay? And misuse is when, he defines it as over-reliance on automation, which can result in failures of monitoring or decision biases. And so what this means is that I actually trust the system way more than I should, and I'm not intervening when I actually should be. And so this is a great example of this. So Dr. Alyssa Howard down at Georgia Tech did some research. Again, this is not really an autonomous emergency robot, but she basically, her and her lab created this vehicle, this robot that says like emergency around the bottom. They'd have someone start to do a task, and then they'd simulate an emergency situation where there was smoke in the hallways, there were like emergency alarms going off. And they would then have this robot kind of be in the hallway when the person walked out, and the robot would like kind of use these 2 things on top to try to motion it towards an exit, right? And what was incredibly interesting, and this is what this GIF is basically, is of the machine being operated to just circle around in a room, right? And this person just following that robot around. And there were other cases where it would try to like motion them towards this door where it was like there was like too much stuff for them to get through. And all these other cases where essentially there was too much trust in this particular system. Now you can definitely talk about like whether, there needs to be further study, like is this replicable, things like that, right? But I think what this key aspect is trying to point at is that maybe a robot was the wrong decision in this case. Right? Maybe the robot is inspiring too much trust in a person. Where, because the problem is that you actually don't want complacency during certain types of emergencies. You want people to get the hell out of the building, and you want them to do it efficiently and fast. You don't want them to be kind of like, oh, I'm going to be calm and I'm going to get out of this building, right? So for this particular case, the interface or the way that this interaction took place was maybe too calming in some way, or too rigid, or whatever. And so that's misuse. The next one is disuse. And so this is the classic example of where I don't trust something, and this was the case for our startup, that in our case, they just started setting all the tables themselves rather than depending on the automation, right? This is also something where when you look at something like ICUs or all of these automation systems around monitoring of people within hospitals, I don't know if you've ever had the displeasure of being in like an ICU room, but like alarms are going off all the time. And as a civilian or someone who's not part of the medical community, it's harrowing, right? Like you're like, why is all this stuff going off? You go and get the nurse walks in and just presses a button to turn it off, right? There was a great New Yorker article that talks about this where something like 10,000 different alarms go off per bed every day, right? And so the problem we want to avoid is that this type of notification, too much notification, is causing a disuse or a distrust within the systems. And so that's where there's too little trust, right? And the last aspect is abuse, which is one that after now taking this tutorial, hopefully you will not encounter, because abuse is really about automation of functions, but without due regard for the consequences of human performance, right? So this is generally, in these papers, a lot of the automation, academic research refers to operators as the people that are actually operating something. First to designers as the people that are actually creating systems. And then there's management or executives that are wanting that system to exist. And the fact is that abuse most happens whenever you have this case of management and design not caring about the operator. And that is pretty much the antithesis of what we're talking about when we talk about design thinking, right? So you're basically ignoring all of the empathize step. You're going with whatever assumptions you have as a designer and you're just building it. And not testing it or anything. So I think it's a very interesting and important thing to consider when we talk about building these types of autonomous systems. So how do we build trust? And one of the things that I've thought a lot about, and oh yeah, question.
Sorry, you mentioned abuse. Would what happens in a hitchhiking robot count as abuse, or is that a different?
No, it's not covered in this. Like, so he was just talking about the hitchhiker bot that I think was able to get around Europe or all of Germany, but then it hits Pittsburgh and suddenly it's on the side of the road destroyed for some reason. And so I don't think it's like disuse. I don't think it's related to this type of trust and automation, right? It's more the fact is that some people personify machines in certain ways and other people don't. Right, and so that's where I think it probably comes down to. It's a very interesting question, this idea of like whether people should be polite to autonomous agents or not. It's a very interesting question. Will it cause people to start to reduce what they feel about human beings if they do this? Or is there a real distinction between these types of objects, right, and people?
I know that there was a worry, and I think Alexa maybe in the home as well.
Yeah.
Basically added a kid mode where you have to ask it politely.
So be polite. You force politeness for kids and stuff like that.
You want them to learn to talk to people by like.
Well, but you know what? You know what's interesting to me is this idea of like voice interfaces. The idea of being polite to another human being is because you care about them in some way, right? And you care about them in a way that is through that interaction. And so to me, I don't know. I wonder whether saying please to Alexa or Google Home is really a skeuomorphism, right? From the standpoint of we're taking how humans interact with each other and then applying it to devices that actually don't care. Right? So, I mean, the way I use Alexa is I just say, Alexa, weather, right? Rather than, hey, Alexa, do you mind if you tell me the weather right now? I'd really appreciate it. So that's one of the things I would say. Yeah, great question. Yeah.
What about abuse to the autonomous vehicle?
Yeah, so I mean, again, I don't think that this is not covered in this idea of trust, right? Like I think that there are cases where probably neglect or disuse will cause people to devalue tools, but this gets back to like how we consider our tools important or not to us, right? And everybody has a different perception of that. So I don't really cover that a lot in this talk, unfortunately, but it sounds like I should talk about it a little bit more. Yeah. No, there's always going to be people that are, I mean, adversarial examples are very interesting. I mean, I did a talk about adversarial product management, and I think the idea of how are you constantly poking or prodding at these constraints is very related to that. And in the case of like adversarial examples for image classification is an example of where it did not generalize in the right way, right? And it didn't do it in a way that actually matters for the rest of the world or our operation within the world, potentially. So anyways, we'll move on, but great. So how do we build trust? I thought a lot about this when it comes to just like teammates. So the idea of that there is some type of minimum bar in the way that we as human beings operate with each other. And it's across many, many, many different dimensions, right? But I think it's very similar in the case of machines. Now, trust is a very, very like complicated, overloaded suitcase type of term from the standpoint of there's papers that try to create these complicated system diagrams about everything that goes into trust, and I don't think that's really valuable as much. It's more about like what do people perceive as trust and how they take action. And when it comes to things like automation, there's some bar where below that bar you actually lose trust in the system. And so based on all of the automation like papers I've read, it sees things like no communication of the state, like the illusion of control is broken in some way. Right? The operator is not taken into account, doesn't allow intervention. Really simple mistakes are something that people do not forgive automation for. But the idea of above that is where you're starting to build trust with the actual person. So is it interpretable? Are you allowing them to build expertise on top of whatever the systems are that you're building? Does it help them avoid mistakes? And then, does it actually help them make good decisions, or does it actually make good decisions itself in a hard case? And then the reason why there's question marks at the top is that it really depends on what's valuable to the people, right? And that's where testing comes in a lot of the time. And one thing I wanted to touch on a little bit is what about accountability, right? This is an example of, so this car is trying to make that exit, but though the car's okay. Don't worry, the car's fine. The car made its exit. So if this was an autonomous vehicle, that would have not been an accident, right? Like, it would not have been monitored in the same way as other autonomous vehicles are monitored for accidents. And so the accountability is really a big issue when it comes to a lot of these systems, right? We all sign kind of blindly these terms of service that take away any responsibility or accountability from a lot of the companies that we utilize services for. And so one of the problems, and this is a really great paper about what they call moral crumple zones, in that the human being ends up being that moral crumple zone because we have someone we can blame, right? And maybe an example where it gets even harder to understand is this is called the Thurrock 25, I believe. And so this was a system for treating types of cancer with radiation. And so there was a point where they had released new hardware and software, and they updated software, and it ended up killing a couple people. And the reason why is that there was a mechanical locking system that existed in one version of the hardware, and then the software would detect that and then not allow the radiation to go. And then the operator would get an error message that said that the radiation had fired. Unfortunately, during one software update, the interlocking system was no longer used. The software did not say that the radiation was administered, and it said that there was an error. And so what ended up happening is the operator would keep applying the radiation over and over again. And so the question becomes, right, whose fault is that, right? Who's accountable for this particular problem? And it's a very, very hard question because we're talking about lots of very, very complicated systems integrating or interoperating with each other to turn into something that is more complex. And so, again, this is another, Accountability in a Computerized Society is a great paper, but accountability can therefore be a powerful tool for motivating better practices, right? And maybe this is the question to all of you, is that when we talk about design thinking or being human-centered when it comes to AI, how do we consider these things? And again, there's lots of people that talk about ethics. I don't think that sending every computer scientist or machine learning engineer to an ethics 101 course is going to solve this problem. It's more about how do different disciplines work with each other more effectively to understand what's actually going on? And I think through design thinking and human-centeredness, I think you get to that. Next thing I want to talk about is mental models. And so this comes from Don Norman of, again, our favorite book, The Design of Everyday Things. But he did a paper that was in '84, I think, that was about calculators. And the thing that was interesting about calculators is that this is a 4-function calculator. How many people, when they start using a calculator, do they hit clear 3 or 4 times? Yeah, probably everybody. Whoever's not raising their hand is a liar. But what happens is that we do this for every single calculator that we use, even though it may be a scientific calculator, even though it may be a 4-function, even though it may be a different type of calculator. And the reason why is that we've created a mental model that for all calculators, this generally clears the memory. It's not specific to that particular case, but it works for us overall. So it's a mental model that we've created. And so, I think what Don Norman is saying in this paper, and I think with a lot of things, is that we need to stop trying to find elegant mental models, right? And this is the example that I would give is that anytime that you've talked to someone that's maybe like very brilliant at building things, they build something and are like, this is exactly the way it should be built, and then you try it out and you're like, this doesn't work at all for me. Right? Is that they use their logic or their assumptions about the world to build something that they thought would work for everybody. But the reality is it's about each individual mental model that matters. And when we talk about why is it so hard to build great things, is because the mental models that people have are not only based on their past experiences and current personal biases that are both mental and physical, right? But the fact is that to create something that is really useful for human beings, you need to create something that is messy or sloppy. And so that's where, I think we're going to start thinking more when it comes to AI and machine learning about how we understand these mental models. It's not only things like, theory of mind and how do you start to understand someone else's understanding of the world, but also how are we now building ensembles to help with these different types of cases that people need help with. And so specifically, I just want to say like our models are not our users' models, right? And even though when we talk about design thinking, a lot of people are like, well, I'm building this for myself because I'm a user. You're really not a user. You have a different viewpoint based on the fact that you're building something in the first place. So how do we understand mental models? And this maybe gets to testing when we talk about the kind of regular way that design thinking thinks about this. And this is user testing, right? This is pretty common, right? You put a prototype in front of someone, you ask them to do something, you observe what they do, you try not to ask leading or biased questions, you try not to ask yes or no questions. You try to get them to just understand what they're thinking about. There's nuance, though, in when we talk about AI and machine learning systems. It's not just about this idea of can they get the happy path of the correct operation, but how do you start to simulate things in your prototypes that would be either false positives or false negatives, right? Like, what does that mean to them? Do they intervene in some way? But also other scenarios like giving feedback, and then the idea of like state communication, abstractions, affordances, and kind of interpretability in general of what is going on. And so, we've tried to get to this. This is a list of questions you can see in the slides, but maybe the ones that I think are most interesting are like, after someone utilizes a system, and it could be a completely fake prototype, is how do you think the system decided that action? That to me is getting at what is their mental model to understand what is going on. I think the idea of just asking people whether they trust the system, even though it's not quantitative in some way that they have trust on a scale of 0 to 10, just understanding like what is it that they actually consider to be necessary to trust something. Was it more or less than before? Like what was their initial expectation about trust? And then after seeing some type of situation, what does that mean? So we did this during our field service operations. This was one particular test where we collected something like 120 observations. And again, we do really small like experiment sets, right? We'll talk to like 3 to 5 people, which in the world of like usability, you get to about 80 to 90% of usability issues a lot of the time when you get to 3 to 5, right? It's not always the case. There's always like that weird 10%. But in this case, we would talk to about 4 or 5, I think in this case, dispatchers. We had them utilize this web prototype that we had built in InVision. We had them do basically job creation, scheduling, and then updating. And out of that, we collected, like 100-something particular key insight things. We then did a bunch of affinitization, which basically just means like grouping. And we took all the ones out that had something to do with the prediction or artificial intelligence functionality that we were faking in the prototype. And then it was actually our designer, Leah, who had the idea to display it in this way, which is the vertical axis is actually understanding of what the machine is doing. And so above I understand, below it's I don't understand at all. And then from left to right, it was either positive or negative valence. So like, did they like it or not like it? Down at the bottom, ends up being like things we need to go back and work on. So these were experiences that didn't make sense. We didn't train them. Like, training is maybe like a lazy way to get people to utilize software, but we like in whatever way we ended up not fulfilling whatever their expectations were. They couldn't understand the interface. They didn't know what to do. They didn't understand what was happening, basically. In the upper left-hand corner, we actually start to see validation of things where these are good places where they liked it and they understood. These are good things for them to actually, for us to automate in some way or to build interfaces or actual further validation of the concepts that we had. And then the upper left-hand corner, we interpreted as job security issues. So they knew what was going on. They did not like it whatsoever, right? But I think another way to interpret this is not just job security, but the concept of there are aspects of their jobs that either they like or feel are important that the machine doing actually doesn't help in some way. And so diving into that a little bit more, I just thought this is a very interesting way to kind of visualize these types of things, but I thought this was really helpful when we were doing our user testing. Yeah, and then moving on from that, once you actually have built out your prototypes, there is still this idea of like prototyping with your data, right? And so a lot of the times when we build out proof of concepts, we're not rolling our own models and collecting all the data, cleaning and training it. We're doing a little bit of the sampling of data and then shoving it into one of these main services like AWS or Azure or whatever to try to understand if we can get better than random with something right off the bat. And I would just go on to say that this is from FirstMark. This is the landscape of AI and machine learning companies in 2018. There's a lot of possibilities for you to just utilize this stuff to even just understand from a prototyping your model standpoint. We can do a lot of this work without ever having to touch TensorFlow or whatever. And in the end, it's about repeating and remixing. So when we talk about, you've just gone through this entire series of steps: empathize, define, ideate, prototype, test. But the truth is as you become a practitioner and you start to become more familiar with design thinking as a framework, you're actually going back and forth between these things within a project over and over again. And it's not just doing one. I mean, you kind of do this if you look at Google Ventures Sprint book. You're kind of doing each of these steps for each day, almost. And so you start to learn, though, that you're going back and forth and doing that. So as final thought, want to revisit this question: what does design thinking have to do with AI? And I want to start with a brief interlude about chess. I'm not very good at chess personally, but it's something that I find really fascinating because we're 20 years post a human being beaten at it, right?
Well, and we're like 16 years post the last human being.
Let me do my presentation. So it first started back in the 60s, right? This is a documentary called Computer Chess, where people have always been, they're using machinery way before this, 100 years before that, right? Where people have been interested in chess as the game that is really about intelligence, right? And so this is actually, Kasparov being beaten by Deep Blue. And we've gotten to this point where, he then, after learning from that, this is a centaur from Pompeii. But later on, when he started to do these tournaments where you were including humans and machines together, the weak human and the machine, but with a better process, was able to beat everybody else, right? And that was true for a couple years. Unfortunately, now with things like AlphaGo Zero, probably we're post humans being impactful or helpful at chess, right? So does playing chess matter anymore? How many people are playing chess today? Right? And I would say there's probably more people playing chess than before. There's probably, So chess, I guess I would say, it probably still matters, right? And human purpose in this case of chess is not just to win the game, right? It's not just to do that. It's actually to interact with another human being. It's to understand how biases or interactions take place. And that's really what chess is about, right? So, my final thoughts about this before we start to take some questions, but we really give machines their purpose, and that is something that we should just be very clear about, right? You should be focusing on these problems. You should be focusing on the people that have these problems rather than just like the new toys. Building these systems is a journey, and you need to iterate and learn still. And design thinking, I think, provides a framework for constant learning, and we will continue to build these organizations where we're teaming these two things together. And I hope that some of these techniques that I showed you will help you really get at kind of how you interoperate between humans and machines. There's still so much to talk about when it comes to human-computer interface, but this is a good start. And then finally, design thinking really focuses AI and machine learning on the human element, which is most important. So I'm, from Philosophie. Of course, more than happy to shill for 5 seconds about Philosophie, but we do a lot of different things, including small teams. And if you wanted to talk to me sometime after this particular tutorial, just give me your card. We can set up 30 minutes. And thank you very much. Yeah, and if there's questions, I'm happy to pass around a microphone, or we can just keep shouting at me if you want. Is there anything that I didn't cover that people thought I should have covered? Like any questions you have that are outstanding? No? All right, I did everything. Oh, yeah, all the way in then.
Somebody in the beginning mentioned like value, how you could just value this. You run into cost often, where what comes up in the prototype design thinking test phase tests well, but it costs like $2 million.
Yeah.
How do you manage that piece after executives walk out of the Friday session in your Google Sprint?
Yeah. Well, Yeah, so the question was like, how do you deal with cost of building or training or even maintaining these types of systems could be very large, even though you validated the need in some way. And I think this gets back to there's a fallacy within product management that the way that you should do all prioritization is based on effort and importance. And the reason why is that I think we over-constrain ourselves by stopping us from being able to do something that we could do in some way as a smaller thing than as a larger thing. And so what I would say is like, you know, when I talk about effort versus importance, it's usually this 2x2 where you have the upper right-hand quadrant of like high effort, high importance is pie in the sky type of stuff. But the truth is that validation gives you an understanding of what you would want to solve about that problem that could be more manageable if broken into smaller pieces or validated in smaller ways, right? You know, so you're absolutely right. Like the idea of building, you know, like if you, for whatever reason, ended up doing all this work and then you create a prototype that's some type of super intelligent artificial intelligence, you know, system that answers every query perfectly and everything like that. I mean, you should be doing these adjustments through this process, right? It should be engineers in the room that are doing this as well. But I think preemptively saying that something is not possible altogether closes off too much thinking. So there's a balance, and there's always about trade-offs, and it's always about prioritization, right? And so I think keeping that in mind, and that's why you want to have both designers, engineers, and product people and executives in the same room, because there's the other way too, that you could build a system that is very simplistic to utilize, but if it's hard for people to adapt into their workflows and processes, you're doing the same thing just in an opposite direction, basically. So it's about getting everybody together to build alignment, basically. Yeah. Yeah.
So you covered a couple of times, right? AI is not the stardust, or it's not a hammer that
Yeah.
would drive every nail or build anything with. Yet that's the attitude of the industry. That's the hype that's going on. So how do you deal with clients who come to you with that expectation? How do you
Yeah.
take them through the process of saying, well, let's focus on the problem?
Yeah, I mean, I think part of it is, like I kind of did in the beginning of this, is pulling back what are these expectations that are just not true, probably, and then rebuilding that back up to say, here are the things that are possible. I mean, the biggest issue is that, especially when you talk about executives or managers that would want to do things like this based on just phrases that they've heard, or kind of, you know, people are hyping up things that they're doing that is actually more than what they're actually doing. This gets to maybe more organizational problems. Like I would say that for consultants that do even design or whatever, you get meta enough, it's actually organizational problems. Like usually the reason why people will hire other teams is because they can't in some way, right? Like one of the things that we help people externalize is failure. Right, so we're a pioneer team that goes off and dies a lot of places before we build something or find out something that's helpful. So, I mean, I think one way to think about this better is that if you're connecting the high-level strategy of an organization to day-to-day action and you're allowing flow of information both directions, you're way more likely to have cases where people are learning from the front line of what is actually possible. Right? Like you should have data scientists or people that are immersed in the data that we're talking about actually be part of these conversations. And so that idea of like inclusion and bringing people together, I think helps avoid a lot of those problems. Now, the other thing is like getting back to that idea of biases or assumptions about the world. Again, running things like dominant logic, running things like bias types of identification through randomization, I think is a novel way to do that. I'm still working on how that works, but that's something I think is helpful too. Yeah, you're welcome. Any other questions or? Yeah.
So, how, in your experience, how have you seen organizations transition from like a data science, machine learning sort of specialty into the AI world?
Well, I mean, I don't think there's really much of a difference, in all honesty. I mean, these are all just terms, right? Like people, like I was just talking to someone about this earlier, but it's like, you know, there was a time when it was like data warehousing and BI, and then suddenly it's big data, and then now it's data science, machine learning, and AI. And AI has been around for 60 years or something like that. So, I mean, one of the things that I would show up there is that if you want AI, like there's a great graphic of tic-tac-toe solved. Right? Like that graphic is technically AI in some way. So I think it ends up being whether people just call themselves AI or not. But I think like good user experience for a time, like, and I still hear this some of the time, is that we're going to go to this industry and we're going to actually use technology in this industry. Not like people don't have technology today, like they just bang stones together. And then we're going to build a great experience for this. And that's going to be the differentiator that we have, right? We're going to see the same thing with AI in the sense that it really doesn't matter what you call it. Like the idea of doing automated decision making in some way that is intelligent and is actually in some way either helping humans do a better job or taking over the boring and bad parts of the job. I think it's this hype cycle thing. But yeah, if I was doing my startup Complete Seating today and I was raising funds, I would say it was AI for restaurants, right? So, yeah. Yeah. Yeah, so the question is like how you do contextual inquiry in a way that doesn't make people act differently. I mean, I think one of the things that's very key is having solo one-on-one conversations with people. Like I think the biggest mistake is there have been times we've tried to work with clients where they'll be like, okay, yeah, we understand you want to do a bunch of user interviewing. We're going to get all of those people in one room and we're going to do basically a focus group. And that's like the worst case. And the manager will be in the room too, right? And so that is like literally the worst way that we could do an interview. So getting into a one-on-one situation, building a rapport with person, but not in a way that's like overt. I mean, I think this is where there's, again, I'm not an ethnography like expert, right? But when I do things like research, it's about building a certain amount of rapport with people so they feel comfortable, but it's not about me looking smart, right? I think that's one of the mistakes that people make when they're trying to do this is they're constantly trying to like intervene and interact in some way that they look good, but it's more just about you sitting back and just saying, hey, whatever you do is acceptable to me, right? So I think that rapport aspect is good. And then also just being in proximity with someone in a truck, like they started to think of me as like a trainee that they would have, right? And so they're joking around, they're making, in some cases, very inappropriate jokes. But, that idea of just like being there for enough time as well. And then, yeah, so it's like those types of things, building rapport, just shutting up, right? And then being there for enough time, I think gives you those bases for those things. Now, robotic process automation field has been thinking about this for a while though, right? Like there's applications you can install in computers to understand the chaining of things for different tasks. And so I've been thinking about that more about how if I can't always get on site for a very long period of time, starting to use tools like that. And this gets back to that design thinking is one framework, right? It's one tool set. And so how do you use all these things from all these other places to combine and do better practice yourself at your end goal? In which in our case, it's like helping provide more understanding of the way something works, being able to provide a direction to a company that is meaningful to their strategy, right? Like, so anyways, it could be any set of tools. Yeah. Any other questions? Yeah. Yeah, so in those particular cases, they were about 45-minute interviews where we had an InVision prototype. We had a set of tasks, I think 3 or 4. And then we would create so in our world, like the product person will create these interview guides and then do the scheduling and do the actual interviewing in some cases. We would do that. There would be someone that would be taking notes that would write down interesting observations that would include not only things that they said, but what they did or what they saw. And we started getting better. We started using something called Rainbow Sheets, which is by Tomer Sharon. It's just a way to like collate different pieces of data into a way where you can say like X out of Y people did this thing. And it also keeps you honest because it makes you actually say what you expect to happen or not up front, right? And then from there, it's basically a bunch of raw notes. We take out the ones that we think are important. And in this case, we had them on 3x5 index cards. But you could do this with like Mural, which is a software platform for like co-collaboration, and then put it up on the same thing and kind of like get people to, like in this particular case, like up here, what we would do for this, we'd basically say like, I would put it up in the center and I'd be like, where do people feel like this going? And we'd like move it around until we found that everybody was like accepting of the positioning, basically. Yeah. Yeah. Well, no, not the people, not the users, but like the group. There were 2 other designers that were on the project with me at the time. So we were all in the interviews where we'd all watch them, and so we would then kind of do this together, right? Sometimes we do blind voting where it's like, 1, 2, 3, where we'd hold up our fingers and we discuss differences, things like that. It's like planning poker. If you've ever done planning poker, it's like that, but it's for like understanding the observations. And then that's how we would get this graph, basically. We've been starting to look at how we actually use things like automatic transcription for these things. So for the last project I just came off of, we did something like 30-something interviews over the course, and we actually even did like a VR component, and so we have these like crazy videos of like VR and everything, where we then push that into something called Temi, which is a transcription service that does automated transcription. And then we were taking those and then turning those into what we call nuggets that would go into an Airtable. And this is stolen straight up from Tomer Sharon, who's really like smart guy who used to work at Google at the head of UX, and then I think he was at WeWork and he's somewhere else now. But that idea of like creating a database of things that you can utilize later. And so I'm wondering, and what I'm going to do now that we're finished with this project, is I'm going to take the set of all the things that we actually pulled out of the transcriptions and put into nuggets, and then run that through AWS comprehension services to understand what the particulars of those are, and then compare those to the ones that we did not nuggetize. And start to understand like what does it mean to be something that's worth nuggetizing, right? In this case. And so maybe we can automate all of this, where we just record the conversation, it gets automatically transcribed, and there's a list of nuggets that are recommended as being important, right? So anyways, that's the dream. Of course, it's not going to work exactly that way, right? And it's going to fail an awful lot. But that's an example of where, like, even in our processes, we're trying to utilize these services off the shelf to help make our lives more efficient. Because I'd much rather kind of think, there's nothing, I don't think we'll ever replace the idea of sitting in that interview and just watching it. But the idea of doing synthesis afterwards, I think, is really helped by these types of tools. Yeah. Yeah, what other questions? All right. Well, cool. So you can find, I'll be up here for a few minutes. You can find the slides, links to resources. If there's something up there that you need but you can't find it, just let me know, email me. And like I said, if you want to give me your card, I'm happy to set up some time just to chat. I will not sell you, but I just like to learn about what are your problems and experiences with building these types of systems inside other organizations. So thank you very much again for taking the 3.5 hours. Thank you.